Okay. So keeping up with this whole hourly wage and getting a raise that we've been talking about since Tuesday. Tuesday you drew the slips of paper with your hourly wage on it. Yesterday we talked about getting a raise. After much thought, your boss has finally decided on permanent employee wages, which are randomly assigned using the probability distribution X given below. Additionally, at the end of the year, she will give her employees an hourly raise. The pay raises are assigned randomly according to the probability distribution Y given below. So here's the hourly wages that are going to be randomly assigned with these probabilities. And here's the raises that people will get at the end of the year, assigned based on these probabilities. We are going to assume that X and Y are independent. We are going to assume that X and Y are independent. I would like for you guys to find the mean, the standard deviation, and the variance for X. The mean, the standard deviation, and the variance for Y. And remember, the variance is the standard deviation squared. So use your graphing calculator to find the mean and the standard deviation. Use the graphing calculators to find the mean and the standard deviation. Once you find the standard deviation, you're going to take that number and square it to get the variance. So take a moment to do that, please, for both X and Y. Once you find the mean and the standard deviation, using the lists in the calculator, you're going to take the number for the standard deviation, whatever number you write on this line right here, and you'll square it to get the variance. So what did you get for the mean of X? What did you get for the mean of X right here? 11.85. And we're rounding it to 2 decimal places since we're talking about money. Typically, we'll take things out 2 or 3 decimal places depending on context. But in this context, taking out to the nearest cent makes sense. That 11.85, we call it the mean of X, or mu X. What was the standard deviation of X? 2.21, 2.22, depending on how you rounded. If you wrote $2.21, I would accept that. I'm not going to get picky over a penny. This is sigma of X. And then the variance, you're going to take that value for the standard deviation, $2.22 or $2.21, depending on how you rounded, and you're going to square that number. What is the variance? I got 4.93 with the way I had rounded that. You should get something reasonably close to $4.93. This is the standard deviation squared. What did we get for the mean of Y? 1.6, or $1.60 if we're talking money. If you wrote 1.6, I would be fine with that. But we do want to work in context wherever we can because they're often looking for context on the exam. So putting that dollar sign on there and making sure that it goes out to 2 decimal places is one of the ways that we can make sure that we work context in. This is mu y, the mean of y. What was the standard deviation of y? 0.91, 0.92, depending on how you rounded. If you're off by a penny, that's fine. This is sigma y, standard deviation. We use sigma. Remember, sigma looks like a circle with a little flag off the top, like a toupee flying away in the wind. And what is the variance of y? Yes, about 84 cents. That is the sigma of y squared. So far, so good? All right. So we have the probability model for x. We have the probability model for y. We have the mean of x and y. We have the standard deviation of x and y. And we have the variance of x and y. We're going to let n be the new hourly wage for the upcoming year. So they're regular assigned wages, x, and then the raise amount, y. So we're going to do x plus y. What are all of the possible new hourly wages for the year? What are all the possible new hourly wages for the year? We're going to make a list. 10. Why 10? 9 plus 1. They were making $9 an hour and they got the $1 an hour raise. So 10 would be the smallest number on my list. 12. 13. 15. 16 and 18. So this is $9 an hour plus a $1 raise, $9 an hour plus a $3 raise, $12 an hour with a $1 raise, $12 an hour with a $3 raise, $15 an hour with a $1 raise, $15 an hour with a $3 raise. What is the probability of getting a $9 wage and a $1 raise? What did we say about x and y at the beginning? They're independent. If they are independent, and I want to calculate an intersection, an and, how do I do that? What'd you say? We don't subtract them. You're close, but no. What'd you say? Not add and divide. What do we do if I want to know the probability of A and B, and the two events are independent? We could do a tree diagram. There's an easier way, but yes, we could do a tree diagram. Let's think about it with a tree diagram. Multiply. In this case, because the events are independent, my tree diagram we always use for dependent, although it also works for independent. So I would have my probability of the $9 an hour wage, so 0.3, and the probability of a $1 raise, which would be 0.7. I would multiply those two together to get the probability of the intersection, the probability of the and. So this is what it would look like with my probability notation. Probability that x equals 9 and intersection y equals 1. We're going to multiply 30% for the $9 wage times 70% for the $1 raise. And we end up getting what? 0.21. 0.21. So what's the probability of getting a $9 wage and a $3 raise? I want you guys to write this out with the probability notation down here. Show me what you're multiplying together and find the probability. Use your notation. show the multiplication, and write down your probability. Probability notation should look like this. Probability that x equals 9 and intersection y equals 3. What are we multiplying together? Yep, 0.30 and 0.30, and that ends up giving us what as a probability? 0.9 or 0.9 or 0.09. My apologies. I think I said the wrong thing. I'm pretty sure everybody said the right thing. 0.09. Okay, so that's how I calculate 9 and 1, which would be this $10 an hour. Here's how we calculate 9 and 3, which would be the probability of $12 an hour. I would like for you guys to fill in this table. What's going to go across the top, though? Because I think we already have that. Yes, 10, 12, 13, 15, 16, and 18. Those are all the new possible hourly wages. We've got these first two probabilities, right? What goes here? 0.21. What goes here? 0.09 from right here. All right. Go ahead and calculate to fill in the remainder of the table, exactly like what we did on parts B and C. Think of what you had to do to get $13 an hour. Again, $10 an hour was 9 and 1. $12 an hour was 9 and 3. Fill out the rest of the table with the probabilities. And once you get all of your probabilities filled in, what should you check to make sure about those probabilities? That it adds up to 1. So find your probabilities and then verify that they add up to 1. To just do regular calculator stuff. Second, and the button right next to it. Do you see how above it says quit?
Thank you.
You're welcome. What is the probability for 13? 0.315. Thank you for taking that out to 3 decimal places. What's the probability for 15? 0.135. For 16? 0.175. And finally for 18? 0.075. And if you add all of those up, those do add up to 100%. All right, so just like I had you do for X and for Y, each individually, I want you guys to calculate the mean, the standard deviation, and the variance for this new random variable N. calculate the mean, the standard deviation, and the variance for the new random variable n. What did you get for the mean of n? $13.45. $13.45. What about the standard deviation? 2.40. Variance? 5.76, 5.77. It seems a little cumbersome if anytime we want to combine two random variables, I need the entire probability model for my first random variable. I need the entire probability for my second random variable. Then I find all of the possible outcomes and calculate all of the probabilities for my new random variable. And then I use my lists. Let's see if we can come up with a faster way of getting the mean and the standard deviation for this new random variable that does not involve me having to come up with all the possible outcomes and all of the probabilities. I want you guys to look at the mean and standard deviation for x and y. Can you see anything that you could do with x and y to get this mean? Add them. The means, add. This is the mean of x plus the mean of y. Those just add together. So even if I don't have the entire probability distribution for x and for y, if I know the mean of x and the mean of y, I can find the mean of x plus y. Does that same trick work for standard deviation? Can I just add those two together? No. What about for the variance? I want you to go back and look at x and y, look at the variance for x and y, see if that same trick works here. It does. The variance adds. This is the variance of x, sigma squared of x, plus the variance of y, sigma squared of y. So I can add my means together to get my combined mean. I can add my variances together to get my combined variance. If I have the variance, what can I do to this number to get that number? What'd you say? Not divide by the mean. Square root. This is sigma squared. So we're going to undo that by square rooting. Check that for me. See if 5.77, when you do the square root, gives you approximately 2.40. So my means add, my variances add, standard deviation doesn't. Most of the time they don't give us the variance in a problem though, but they will give us the standard deviation. If I have the standard deviation, how do I find the variance? Square it. So if I get the standard deviation of distribution A and the standard deviation of distribution B, I can square them both, add them together, and then square root that answer. And that gives me the new standard deviation. Now there is a little caveat here. We're going to summarize what we just did at the bottom. The mean of my new variable, mu of n, is equal to the mean of x plus the mean of y for n equals x plus y. The standard deviation of n is the square root of the combined variance. And the variance of n is just the sum of these two variances. Here's the part that we got to be careful about. These two pieces, variance and standard deviation, so very much related. I can only use those formulas if x and y are independent. If x and y aren't independent, I can still calculate the new mean. This works always. So whether x and y are independent or not, I can do this. If x and y are independent, then I can also calculate the standard deviation. If x and y are not independent, then I cannot calculate the standard deviation. And I'm just stuck. Before we flip this over, does anybody have any questions? All right, let's flip this over on the back side. When we are combining random variables, the mean of x plus y is the mean of x plus the mean of y. If I wanted to do the mean of x minus y, I do the mean of x minus the mean of y. Pretty straightforward. Standard deviation is where we have to be careful, though. What do you notice about when I want to add my variables versus when I want to subtract my variables? What do you notice about the standard deviation formulas when I want to add my random variables versus when I want to subtract my random variables? They're the same. We add here, which makes sense because I'm adding my two random variables. But when I'm subtracting the random variables, we still add the variances. When you subtract the random variables, you subtract for the mean, but you add the variances. One does not simply add standard deviations. It must be the variance. Must be the variance. Normal distribution calculations, if I want to combine random variables together and they are both normally distributed, we will use one of these two formulas to calculate the new mean and the new standard deviation, and then we will proceed as normal with a normal calculation. Right. There are 3 questions down below in the Check Your Understanding. I would like you to just do the first 2 for starters. Take about 3 minutes. Do the first 2. Do number 1 and number 2 on the Check Your Understanding. If you want to go ahead and do number 3, please let me check your answers for 1 and 2 first. Right now I want you to focus on number 1 and number 2. If you want to go on and do number 3, before we go over 1 and 2, please have me check your answers first. Make sure you interpret it. So you might have to look back a page or 2 to figure out how to interpret it properly. And yes. So interpret this one and then you can go on and do that one. No, you have to square the standard deviations first. That's what that sigma squared is. Then you add them. Then you square root them. Yep. I'm doing x minus y. So you want to minus those two pieces. You're welcome. Who was it that said my name? Okay. I was like, I know it came from here, but then everybody was looking down when I checked over. That's okay. Nope, that's exactly what you want to do. The only thing is you don't need the p, that means probability, and you're just calculating the mean. So you don't have that, just have this, and then yes, that's correct.
What is the notation? Is this the notation that I'll put for this? Or here?
Yes, so you'll have that at the beginning, and then over top of this whole thing, you'll put a big square root sign, because you're calculating this, which is being represented by d. That's the x minus y.
Okay.
Yep.
So you said I'm putting this.
Yep, put sigma with a little d next to it. Yes, so that it looks just like that.
Mm-hmm.
And then over top of where you're adding these two squared numbers, put a
Square.
big square root sign around the whole thing. Yes. Remember, we can't do that for these. That's the one that we got to be tricky. We're going to do this right here. That's okay. All right. Let's go over number 1 and number 2, and then I'm going to give you another moment or so to do number 3, but I want to make sure that we're working with the right mean and the right standard deviation before I have you calculate number 3. Number 1 says to calculate and interpret the mean of D. What is D? X minus y. And they gave us information about x and y up here. It said x was the number of points scored by the home team. It is approximately normal with a mean of 22.98 and a standard deviation of 9.30. Y was the number of points scored by the away team, which was also approximately normal with a mean of 20.09 and a standard deviation of 9.41. What do I need to do to calculate the mean of x minus y? Yep, that's exactly right. The mean of our new random variable d is equal to the mean of x minus the mean of y. So I do 22.98 minus 20.90, and we get what? 2.08. So this is going to be the mean that we use for part C. That is the combined mean of x minus y. They did also ask us to interpret this. How would you interpret this?
There's a 2.08 increase in points
For the home team? Yes, we need a little bit more, but yes, what you said so far is not wrong. This is not always true, right? It's not always true that the home team scores 2.08 points more than the away team. What other word do I need in there? What does the mu mean? We do want that. What does mu mean? It means the mean. What does mean mean?
On average.
On average. On average, the home team scores 2.8 points, 2.08 points more than the away team. If we were to choose many, many, many NFL games, the idea is that this is over the long run. So if we were to choose many, many, many NFL games, the average difference in points for home versus away is 2.08 points. So what I have seen, I'm trying to share as much feedback as I can from the rubrics that I've seen. They want to see something about in the long run, but they really want to go after that many, many thing. I want to make sure everybody's got this interpretation written down. Making sure that you can interpret the mean in context is going to be one of those things that you guys are going to need to practice on to get that language and verbiage down so that you have this kind of plan to follow when you interpret the mean. But you want to make sure that you are able to interpret the mean in context. All right. You guys ready to check number 2? All right, so number 2, I want to calculate the standard deviation of D, which is the standard deviation of x minus y. When we did the means, we subtracted. Do I still subtract for the standard deviation? Not for standard deviation. We add. Do I just add the standard deviations together? That $9.30 and $9, sorry, not $9, 9.30 points and 9.41 points. Square them, then add them, and then square root them. So we have the square root of 9.30 squared plus 9.41 squared, and you end up getting what? 13.23. Right. Number 3, and I'm going to set you guys loose on this one, but I want to make sure that we all understand it before I set you loose on it. Suppose we randomly choose a game and record the number of points from the home team and then independently randomly choose another game and record the number of points from the away team. What is the probability that the home team has more points? So I need to try to think of a way of interpreting that mathematically. If the home team has more points, which one is bigger, X or Y? Which one means home team? X means home team. So if home team scores more than the away team, then X is bigger than Y. If X is bigger than Y and you subtract them, what kind of number do you end up with? If X is bigger than Y, you get a positive number. Positive numbers are all bigger than what? 0. So what we are wanting to do is to find the probability that when I subtract X and Y, I end up with a number bigger than 0. I get a positive number. All right, I'm going to give you guys about 2 minutes to do number 3. That does need to include a picture. Anytime we're talking about normal distributions, thank you. Not here today. Thank you. Please make sure you draw a picture with this. We will go over this in about 2 minutes. What'd you say? You're going to use this mean, that's the mean of X minus Y, and you're going to use this as the standard deviation. That's the standard deviation of X minus Y. I'll be right there, Jamie.
Because there's a missing assignment that my mom's really worried about. When my teacher told me today, I asked her about it, and she said she took care of it and she just put the grade in. But my mom doesn't see the grade. But for some reason, I'm logged out of Canvas on my phone, and it won't let me log back in, and it won't let me access Skyward on my phone. So there's no way for me to personally check unless I use my computer, like my mom said. But that's like, you know.
Understood. Let's do number 3, and then I'll let you go because we'll have plenty of time.
Tail is where the thing is going, right?
What do you mean?
Like the tail?
Oh, here?
Yeah.
So when do we use inverse norm?
When we have a percentage.
When we have a percentage.
Oh, I'm not doing it.
you say? Can you get a second? Yeah, you can take a second. When you draw your picture, what goes right down the center of the picture? The mean, which in this case is how much? 2.08. Where should you put the vertical line for your boundary at? 0. And then do we shade to the left or to the right? Ooh, let's look at our inequality. The inequality is x minus y greater than 0, so we are going to shade to the right. This is what your picture should look like. Make sure you have the mean of 2.08 right down the center. You need to have the capital N, meaning normal, and then inside parentheses, labeled, you need the mean of 2.08, labeled as mu, and the standard deviation of 13.23, labeled as sigma. You need your boundary of 0 on here, which came from the probability statement, and it is shaded to the right because of the direction indicated in the probability statement. So we are going to find the probability that x minus y is greater than 0. This is how I start my answer off on my page. How do we do that? How do we calculate that? Normal CDF. First number inside the parentheses is 0, labeled as my lower boundary. Second number, 9,999. I used a million. The point is you want something stupid big. Something that is way, way bigger than the third standard deviation over here. Because remember, this graph goes just a little bit past the third standard deviation. We want to go out much farther than that. Question. Would 100 be a big enough upper bound in this situation? I would say it would be. Right in the center, I have 2.08. My standard deviation is about 13 1/4. If I did 3 standard deviations, that would be about how much?
39.69.
Yeah. 3 standard deviations is about 40, right? I add 2 more onto that. 42 is going to take me out to just above 3 standard deviations. So 100 would definitely be far enough away. You are always welcome to go absurdly larger than that. But I want you guys to start thinking in context about how big is big enough, or on a lower boundary, how small is small enough if we round it or if we shaded the other direction, so that you know that in context you are choosing numbers that are big enough or small enough. All right, what other 2 numbers do I need here? The mean and the standard deviation, which should be part of your notation over here. And what do we get for output? What do we get as an answer? 0.5625, 0.5624, depending on how you round. Yep. All right. Nicely done. What questions do you guys have for me? Yes.
How do you know question 3 is asking for a normal distribution?
So back here in the question stem, it said that x was approximately normally distributed and y was approximately normally distributed. And we are talking about combining these together through subtraction right here. When you combine 2 random variables together, if those 2 random variables had the same shape to begin with, when you combine them, either by adding or subtracting, it's going to have the same basic shape. So I knew it needed to be a normal distribution because they used normal and normal up at the top. Any other questions about what we went over today about combining random variables? You guys have about 15 minutes of homework time. Homework is due on Monday, but I am available for questions right now. So I would highly encourage you to make use of this 15 minutes to break that homework out. See if you know how to start the problem. If you don't, that's a great one to ask about. If you look at it and you're like, no, I know what to do on this one, that's probably a safe one for you guys to leave until you're at home working on it on your own.